Yes, it's a wonderful introduction for us. And on behalf of my team, I'm going to present today our work. And the title of our work is Discovery of Actionable Pattern in Big Data Using Information Granules and Meta-Actions with Cost and Feasibility for Emotion Detections. Moving forward to the outline. So today we'll be covering problem definition, introduction, related work, the dataset description, methods, experiments and results, conclusion, and the future work. Internet computer storage, data from users and sensors are piling up. This requires more time and space than a single computer can cope up with. Ecosystems like Hadoop helps to store, process, and retrieve back the data efficiently, excuse me, in a distributed fashion. Now, regular kind of data mining doesn't work there. So there is a particular need to adopt big data. Now, little work has been done in adapting actionable pattern discovery algorithms to big data and action rules in a distributed environment. We have been using our own proposed method, that is vertical data split strategy, using information granules that can handle big data. And our data distribution task then splits the big data to extract action rules and suggest meta actions. Now, problem definition continues. Trigger, social network, blogs, public forum, electronic mail, etc. that provides text. It basically triggers readers' feeling, opinion, or emotion. Mining this data can provide a lot of meaningful insights on how to improve user experiences in different fields like education sector, business field, medical domain, and social field. Now, the data, as they hope to find patterns and trends and the golden nuggets that basically help them to accomplish the goal. Now, for example, how to improve student learning, how to increase business profitability, and how to maybe heal patients, right? Now, customer, if happy, they will buy the product and recommends it to their families and friends. Now, customer review is being provided, student opinion forms are there for the recommendation, improving the products and services forms, and recommending all these services and products to their friends and family if they like. And that's how they are related to this particular domain. Now, the actionable pattern, which we just explained, may suggest ways to alter the user's sentiment or emotion to a more positive or a desirable state from a negative or an undesirable state. Here in our particular work, we have used our proposed method, modified hybrid algorithm, action rule mining algorithm with threshold row, that typically improves the computational performances and provides better scalability with large data sets. Moving on to the next slide. Knowledge discovery in databases, or KDD, is a process that involves the extraction of useful, previously known, and potentially valuable information from large data sets. It helps in decision making, fraud detection, better customer services, predictive modeling, and stuff like that. The example is, for example, diapers and milk. If a person is buying both of them, diaper and milk, then it's certain that the person is going to buy beer at the same time. Now, this particular thing, recommendation in data mining method, is useful in decision making on promotions and product placements, as we can see in the next slide. So the rules take representation of antecedents, that is a if condition, tends to consequent, that is the result condition. So data over here we can see goes through an algorithm and produces rules, and then rules are the if and then statement. So rules take the representation of if conditions, tends to the result. In actionable pattern, the conditions are replaced by sequence of actions to achieve the result. As we can see here in this example just described before, that it's certain that if a person is buying diaper and milk, will also buy beer, right? Over here, beer is the result, and the if condition is diaper and milk. Moving on to the next slide. Information granules are used for solving large human centric problems. Now, what is information granule? It's a representation of small granules from a larger task or data. Now, granule is a subset of data objects that are grouped by similarity, functionality, or indistinguishability. Now, information granule is a process of breaking complex object into smaller pieces called information granules. Opinion mining and human emotion. The word emotion origin dates back to 1579 from a French word. Allen Fox gives a formal definition of emotion. It is a discrete and consistent response to internal or to external events that have a particular significance for the organism. The focus is mainly on text data because of the growth of textual data from sources like email, customer reviews, social networking sites, and so on. And mining the opinion of people has applications in several areas, like understanding what exactly people may like or dislike is critical for making informed business decisions, political decision, improved teachings, and learning techniques. Research focus. So we work on novel approach of using student feedback for courses leveled with emotion and provide suggestions on how to enhance emotions. This in turn leads to better teaching style, learning outcomes, and a comprehensive environment. For this purpose, we use actionable pattern discovery method. As we have seen in our previous slides, actionable patterns are the patterns that help benefit the user to achieve better outcomes. For example, change emotions from negative to positive, like changing emotions from sadness to joy. Here, we aim to suggest ways to improve the state of detractor, customer with negative emotions, to promoter, that is, customer with positive emotions in business, which leads to improvement of net promoter score for the company. Now we extracted action rules by working with NPS data that in turn leads to gain better insightful knowledge on customers' attitudes towards the service. For this purpose, we apply our proposed modified hybrid action rule method with partition threshold row to convert detractor state to promoter state, thus help to improve the net promoter score of the company. Now we focus on the data mining distribution phase of distributed actionable pattern mining problem, where we worked on granularity based method to handle the data distribution task and extracted an intermediate stage of meta action to generate the action rules efficiently. We apply our methods to NPS data to achieve more desirable state and higher profits. Now, action rule mining is one of the actionable pattern mining approach where it helps to extract action rules. And action rules are extracted from a decision system that suggests possible transition of data from one state to another. There are two major action rule mining framework in data mining literature. They are rule-based action rule mining and object-based action rule mining. Now, to see what I mean, the rule-based action rule mining approach extracts intermediate classification rules using Lars approach and then uses it to extract classification rule from complete information system or using the extraction rule from the incomplete decision approach. And rule-based approach is further subdivided into methods that generate action rules from certain pairs of classification rules like discovering extended action rules methods and so on. So here are the example action rules that we have extracted. I'm going to explain the first action rule from each of the data sets. So the first one is car evaluation data, and I'll be explaining the first one, that is talking about if the number of person the car carries increases to more than 4 and the safety changes from medium to high, then the class of the car changes from unacceptable to acceptable. Similarly, talking about the other dataset, mammographic mass data, if BRADS, that is tumor blood consumption, decreases from 6 to 2 and the density of tumor decreases from 4 to 3, then the severity changes from 1 to 0 or malignant to benign. Now, action rule, which triggers changes of flexibility attributes either directly or indirectly because of correlations among certain attributes in the system, is currently known as meta-actions. Explaining the first one, action rule number 8, that is, if benchmark paths ease of completion paths order changes from 5 to 10, then the promoter status changes from detractor to promoter with the support of 3 and confidence of 91.6%. Now, the example meta actions could be train the company professionals to respond to customer better, improve customer services, enhance website design so that it is user friendly for the customers to order the parts, and make the parts ordering quicker. Recommender systems are an essential feature in our digital world as users are often overwhelmed by choices, right? And they need help finding what they are looking for. This leads to happier customers and, of course, more sales. Emotion mining gained attraction in the field of computer science due to the vast variety of systems that can be developed and promising applications like remote healthcare system, customer care services, smartphones that react based on users' emotions, vehicles that sense emotions of the drivers, and so on. Now, scientific studies on human emotions has given two prevalent theories. One is a discrete emotion theory, and the other one is dimensional model. Now, discrete emotion theory states that core basic emotions are served by independent neural systems. On the other hand, dimensional model states that all emotions are combination of core neural sensation. Now, this particular picture shows a complex model. According to the author Posner, in this model, joy is a product of strong activation in the neural system associated with positive valence together. Now, opinion mining can be accomplished through emotion detection. Emotion detection has its root in many disciplines apart from computer science as follows: psychiatry, psychology, neuroscience, and so many other departments. And emotion mining and actionable pattern discovery can help to find certain similarities in social media data mining, educational data mining, and of course, business data mining. Now, this is kind of a related work. So basically, when we think of innovation in terms of education, it can be applied as a teaching technique, pedagogical approach, learning styles or process, and institutional structure. Now, active learning approaches is gaining attention and popularity in higher education, where lightweight team is an active learning approach where students work together in a group, but they have very little or no direct impact on their final grades, right? So this is talking about student emotions about active learning approaches. Now, these are the certain attributes that we have worked with for student survey data, like student emotion, group assignment benefits, and so on. And this is how we have collected the data. So we have sent them a paper, a review form, and then from there we have developed and designed the survey questionnaires. We have pre-validated the questionnaires, and we have used the Google form. Like we have administered the questionnaires using the Google form, and then after collecting the data, we have worked on cleaning the data, and we have used those data in our experiments. So Net Promoter Score data set is collected from customer feedback data related to heavy equipment repair. The entire data set consists of 38 companies. Customers were randomly selected to answer a questionnaire, and service given by customers for 2 companies per year. We have used 70 California and 35 datasets for our methods. So here we can see that how the action is working. The reds, the one mark in the reds are the flexible attributes, including the decision D attribute. It values A and H, so the user wants to change the action from H to A to accomplish the goal. Now, blue ones are the stable attributes. Here, X is object, that is 10 objects and 4 attributes. Now, atomic actions over here, we can see terms means an expression that is A, comma A1 tends to A2, where A is an attribute and A1, A2 belongs to variable A. And A1, A2 are values from A. So if certainly A is equals to A1, then A is called a stable on A1. In this case, for simplicity reason, we use notation A, comma A1 instead of A, comma A1 tends to N. Now here we have set Y, which is on the left side of the rule arrow, and on the left side of the rule arrow, we have A2, B1, and D1. That is objects having property A is equal to 2, B is equal to 1, D is equal to 1. That is X2 and X4 shown in red color. Now set Z is on the right side of the rule arrow. That is objects with property A2, B1, and D1 shown in green color. So there are four sets involved in Y1 and Y2 and Z1 and Z2. The Y's are used for the conditional part of the rule and Z's are used for the decision part of the rule. Now here we are computing support and confidence of action rules. So there are four sets, right? We have just now discussed Y1, Y2, Z1 and Z2. Now over here we can see that what the action rule 1 is saying. So the action rule 1, R1 is saying that if A2 tends to A1 to A2, and if B changes from B2 to B1, then the decision attribute will change from H to A. And then we will calculate the support by this formula given over here and the confidence by this formula given over here. Now, action rule applications. It can be applied in social networks, smart homes, medical domain, education domain, and so on, right? So, association rule mining. To find association rule mining or association relationship among set of objects in data larger database, we use association rule mining, where it says that 70% of transaction in this example that contains X and Y also contains Z. So X and Y is the if condition, that is the antecedent, and contain Z is the consequent or the result. And 70% of transaction is the confident factor. So hybrid action rule mining is an approach that combines the rule-based and the object-based approaches to generate the action rule much quickly. Now, the hybrid action rule mining algorithm works with the information system with, and the first line you can see certain rules, decision forms, decision tools, support, and confident. The algorithm first uses the large method to extract the classification rule that are certain and next generate action rule schema. For each action schema, the algorithm then creates subtable. The hybrid action rule mining algorithm applies the association action rule extraction algorithm in parallel on each of the subtable. Now, this hybrid action rule algorithm is implemented using Spark and it runs separately on each subtable and does transformations like map, flat map, and join. Now, this is modified hybrid action rule mining algorithm with threshold row, which presents a significant improvement over the previous method, hybrid action rule mining, which has a major disadvantage. Like if the size of the intermediate table becomes very large, it affects the performance and the scalability of the method. Now, our proposed method solves this problem, as a threshold row allows the user to control the size of the table and it increases the computational speed. It gives the number of partitions, and the number of partitions change the number of nodes that are executing in parallel. We introduce this to give a more control over the speed of the execution. Now, this is a flowchart. Yes, the more the number of partitions, the more the number of nodes executing in parallel, which is good for the execution time. Here we are describing the vertical data split method with meta-action and intermediate state. So the actionable knowledge extraction algorithm runs separately on each data partitions, with each partitions having only small subsets of larger attributes. We give a new algorithm to generate the meta-actions as the intermediate state before extraction of all the action rules. The algorithm over here gets the pre-processed data, that is the RID and R values as inputs, where RID is the row ID and R value is the list of values for each record in the data. Now the algorithm also takes decision from D from and decision to D2 values as parameter. Then at step 2 of the algorithm gets all distinct attribute values and their corresponding data row indexes. This step involves a map phase and a group by key phase for the Spark framework, where we collect the data row indexes to and the support and confidence of action rules. Now in step 3, we assign the distinct attribute values to old combination, that is C old, to start the iterative procedures. The algorithm runs maximum of n iteration, where n is the number of attributes in the data. During the ith iteration, the algorithm extracts action rule with the I-1 action set pairs on the left-hand side of the rule. Step 6 over here generates meta-action, and step 8 uses flat map transformation on the data to collect all possible I combinations from a data record. Now we saw the combination of attribute values since they act as key for upcoming join and group by operation. We also attach row ID, RID to all combination to get the support of each combination with the use of Spark's group by key method in step 9. So we do sequential filtering in the following steps. And in step 10, we filter out combination. From the filtered combination, we get combination C from and C2 that has a decision from D from value and decision to D2 value in steps 11 and step 12 respectively. In step 14, we join C from and C2 based on attribute names, filter out D from and D2 values since we know the decision action, which is not required in finding confidence of action rules. Now this results in action rules of the form. We then calculate actual support of the resultant action rules and filter out rules that has support at least the given support threshold. Support in step 15 and reformat it in step 14. Now in step 17 and step 18, we perform join operation with old combination and assign values to A from and A2 in step 19 and step 20 respectively. Subsequently, we perform division operation of the confident formula in the same step. In step 21, we join A from and A2 and perform multiplication operation on the confidence formula and reformat it. We now join action rules with support from step 15 and action rules with confidence from step 21 to get the final set of action rules. In step 21, we assign new combination to the old combination and pass the same to the next iteration. Now, student survey data, originally it contained 549 instances and 59 attribute. Data is collected in classes and the data size on the disk is 59 kilobytes for scalability purpose. To test the performance of our proposed method with big data set, we replicated the original student survey data 1024 times, and the replicated data sets has a total of 562,176 instances, and the size on the disk is 58.2 megabytes. Now we perform these experiments in AWS, Amazon Web Services, with 2 nodes, 4 vCores, 16 GB memory, and EVS storage 64 gigabytes. And we will see in the explanation that we had to add an extra 32 gigabytes of memory for the plain vertical data split method. And this method only works for association action rule because it considers only subsets of the attributes. Now, again, for hybrid action rule method, we have used Amazon Web Service and the execution runtime takes 5088 seconds. Now for modified hybrid action rule, again, we have used AWS with same clusters of specifications And we have used a Spark machine learning library in Scala programming language, and our proposed method takes 3900 seconds to complete computation on the replicated student data. Here is a tabular format of explaining all the things, like it required an additional 32 gigabytes for vertical data split method, and then the runtime came out to be 2400 seconds. But with standard memory, it showed an error that is out of memory exception. Now, using the student survey data, using two thresholds, threshold rho and theta, we can see the optimum performance goes to when rho is equals to 5 and theta is equal to 15. We can see the time is 3900 seconds. Here is the first action rule that we have got. Like the table describes 3 different action rules, but I'm going to explain the first one. So talking about the attribute formation, when it changes from 2 below average to 4 perfect, then the number of team members changes from 5 to 7 to 8 to 10, then the student emotion changes from sadness to joy with support of 21 and confidence of 62%. Now here is the business data. While using the business data in AWS, again for vertical data split, it showed out of memory exception. We had to add an extra 32 gigabytes. But with hybrid methods, the runtime was 5,800 seconds, and with modified hybrid method, the runtime was 4,002 seconds. So the first one, again, I'll be explaining in this table. So the detractor state changes to promoter state when the benchmark parts order accuracy changes from 3 to 10 with the support of 2 and confidence of 62.19%. So here are the sample examples in the table. I'm not going to explain all of them. So it talks about all the data sets we have been working on and the action rules that we have got. So same for this table, same for this table, same for this table. And these are the related meta actions that is related to the first table that contain action rule 1 to 5. I want to explain the maybe the second last action rule 4.1 over here. So what it's actually doing is it's breaking down the action rule into granules and meta actions. So action rule 4 talks about benchmark all over satisfaction if it remains same. Then the promoter status changes from detractor to promoter with a support of 3 and confidence of 83.33%. Now, how to achieve this? This is what meta action is used for. Now, if the customer satisfaction is remaining same, nothing has to be changed, right? Because benchmark all over satisfaction remaining the same. Then only the action rule could be achievable. That is, the detractor state will be removed and we will be getting the promoter state. Now, in conclusion, we perform opinion mining in text by detecting emotions automatically. We have recognized emotions from text data. And in this work, we mined student survey data and NPS data. We experimented with student survey data and NPS data to test our proposed modified hybrid action rule mining method. And our method can be applied to following domains like smart appliances, social network, education, improved business revenue, and so many things. Mining actionable knowledge actually puts benefits to identify emotions. Now, since data is growing, efficient data distribution technique is really required. Now, our proposed approach has divided the data in more intelligent way. We have handled data distribution task by splitting the data both horizontally and vertically by using partition threshold row. And we also take intersection of sets with high support within partitions, and we generated the meta actions to achieve our desirable state. Now, in future, we plan to experiment with larger student survey data and NPS data, and we plan to experiment with values of threshold as a percentage of the original data size. We expect improved performance with big data sets, and we also expect the discovery action rules to provide the suggestions on enhancing student emotions, thus overall teaching and learning experiences in the education domain as well as in business domain. Thank you. Questions?